So today we'll learn about asynchronous programming using async and wait in a C#. So we'll go for the asynchronous programming using async await in C# with them. The async and await keywords are introduced in C# to make the asynchronous programming on the .NET platform easier. So these keywords have fundamentally changed how code is written in most of the C# ecosystem or programs. Now, asynchronous programming has become mainstream, and the modern frameworks such as ASP.NET Core are fully asynchronous. So, async and await, these are the two keywords that we have in C# or in .NET. So, on .NET, so it's available in .NET Framework as well as .NET Core, and this will help you to do the asynchronous programming. So, it will help you to write asynchronous code. So, it will help you to implement asynchronous applications. So, asynchronous code or asynchronous, we can say, programs. Now, these keywords had fundamentally changed the how we write the code in C# programs. So, asynchronous programming becoming a part of mainstream day by day, and modern frameworks such as ASP.NET Core is fully synchronous with them. Now, C# has a language level asynchronous programming model, and which allows for easily write asynchronous code without having to jiggle callbacks or conform to a library that supports asynchrony. And it follows what it knows as a task-based asynchronous pattern tab. Okay. Now, so asynchronous programming that we used to do right now in a .NET and .NET Core are very simple, very easy to do using async and await keyword. You do not need callbacks, you do not need conform libraries, or you do not need any kind of, we can say, logical arrangements in the code to perform the asynchronous programming there. So we can do it very easily using async and await keyword on the top of tab. So task-based asynchronous pattern with that. So to execute the code, so if you want to execute the code parallelly or simultaneously, older days, what we use multi-threading. So we use multi-threading with that. So .NET has multi-threading. Right now, multi-threading is also a part of .NET, but it's we can say at the bottom level. So at the bottom level, on the top, we use the async or we use the TPL. So we use async wait or TPL here. So multi-threading. So on the top of multi-threading, we got the task parallel library. And now we have the async programming. So nowadays we are using async programming with that. So nowadays we are using async programming or asynchronous programming with that. Okay. So asynchronous programming makes it very easy. So if you want to use the multi-threader, it's quite difficult. TPL is also a little bit difficult to that, but async programming is very simple, very easy. You do not need a callback, you do not need any kind of context switching, you do not need any kind of communication, you do not need any kind of arrangement. It happens very seamless as you write a normal code in a C# application there. Now, before going to, but the popular mechanism that we have to do the asynchronous programming is using a task-based asynchronous pattern. So we use task-based asynchronous pattern to write the asynchronous, we can say, code here, asynchronous, or do the asynchronous programming using async and await of that. Now, before going to asynchronous programming, so we should have some knowledge of some things. So that's so the first is synchronous. So what are the code that we have written till date? So what are the code that we have written till date are synchronous code, except the Ajax call that we had made using a jQuery. Those know the jQuery Ajax. This is only for those students, but those do not know, do not worry about it. We'll learn it in the further sessions. But except Ajax call, so what are the code that we had written? So we had always written the synchronous code. So we had written the synchronous code. So synchronous code means doing the things one after another. So if you have the 5 lines one after another, so in a synchronous code, so first line will be executed completely, then it will go for the second line will be executed completely, then it will go for third line, so third line will be executed completely, then it will go for the fourth line and the fifth line, like this. So this kind of programming model is called synchronous programming model, where we do the things one after another. So when first is complete, we'll go for the second. When second is complete, then we'll go for the third of that. Now, so third until third get doesn't get finished, so four need to wait. So when four is finished, then we'll go for the five. Now the second word that we need to understand is concurrent. So the second word that we need to understand is concurrent here. So second word that we need to understand is something called concurrent. So first is synchronous, second is concurrent. Now concurrent means doing the multiple things at the same time. So concurrent means doing the multiple things at the same time. So if you want to do the T1, T, so task 1, task 2, task 3, task 4 at one time, so such kind of execution is called a concurrent execution. So such kind of execution is called concurrent execution. So when you want to do the multiple, we can say multiple different tasks at one time. So when you want to do the multiple different tasks at one time, so we call it as an concurrent execution. So we call it as an concurrent execution there. So we call it as an concurrent execution. So in the concurrent execution, we do the different or multiple tasks at one time. So we do the different or multiple tasks at one time. So we call it as in concurrent, we can say execution there. So we call it as an concurrent execution. Fine. Now the next thing that we have is parallel execution. So what we do in the parallel execution? So in the parallel execution, we do the same task, we create the multiple copies of the same task and then run them parallelly. So we do the copies of the same task, so we create the multiple copies of the same task and we execute them parallelly. So we execute them parallel to that. Now the concurrent and parallel, what is the difference between the concurrent and the parallel? So in the concurrent, we do the different tasks parallelly, simultaneously, whereas in the parallel, so we do the same task parallelly. So we create the multiple copies of the same tasks and we execute them parallelly. So we do the copies of the same task, multiple copies of the same task, and we execute them parallelly with them. Now asynchronous. So asynchronous is a little bit different. So asynchronous means not having to wait for one task to finish before starting another task. Now all these four words feel to be similar, but those are not similar. So I'm telling you here a difference. So asynchronous means not having to wait for one task to finish before starting another task. So we do not need to wait for any task to start a new task for that. So in asynchronous, we can start any task anytime, anywhere. So we do not need to wait for a finish of, or we can say, or end of any other task for that. Now to do the, we can say, asynchronous programming, so .NET provides you three patterns for performing asynchronous programming with that. So .NET has three patterns to perform the asynchronous programming. So the first pattern is asynchronous programming model, so APM. So we call it as an APM. So APM is the older option of performing the asynchronous programming with that. So nowadays nobody uses it. So we call it as a legacy mechanism to perform the asynchronous programming with that. And then the next thing that we have is event-based asynchronous pattern. So the next thing that we have is event-based asynchronous pattern of that. And in event-based asynchronous pattern, so EAP, that is again legacy, that is again the older option to do the asynchronous programming, where we club the events together to perform the asynchronous task for that. Now, last option, that is the most popular and the recommended option by the Microsoft, that is called task-based asynchronous pattern. So TAP with that. So task-based asynchronous pattern, the most we can say popular pattern to write the asynchronous code or asynchronous program with that, or to do the asynchronous programming, and that is also recommended by the Microsoft with that. Now, so before going to async and await keyword, we'll try to understand. We'll try to learn about TPL. So we'll learn about a TPL. So we'll have a look at to the TPL of that. So TPL is basically called Task Parallel Library. So .NET got a task parallel library. So the task parallel library is a set of public types and the APIs in the system.threading and system.threading.task. So TPL is a set of public types. So these are a collection of some public types of there, and the set of APIs. So set of APIs. So it has some public types in the set of APIs, and those will be part of a system.threading or system.threading that we can say. So threading that task with that. So these two namespaces, so system.threading and system.threading, the task is required for TPL, and the purpose of TPL is to make the developer more productive by simplifying the process of adding parallelism or concurrency to an application. So parallelism and the concurrency to the application of that. Now before TPL, so if you want to execute some code parallelly or concurrently, so before TPL, so if you want to execute some code parallelly or concurrently, so before TPL, so if you want to execute some code parallelly or concurrently, so we use multi-threading. And multi-threading is quite difficult to understand and implement and write to that, so it has a lot of stuff to that, so we'll not go to that detail, but we can say so TPL is fundamentally it boils down to a task, so it boils down a task, so indirectly we can say TPL is to make the developer more productive by simplifying the process of adding the parallelism and concurrency. So TPL is, we can say, abstraction over the multi-threading. So we can say TPL is the abstraction over the multi-threading, and what we do in a TPL, so TPL is the abstraction over multi-threading, and what we do in a TPL, so we can do the parallelism and concurrency in very simple way, or using very simple process or mechanism of that. Now TPL, that is called Task Parallel Library, basically provides a higher level of abstraction. So it provides you a higher level of abstraction. Fundamentally, it boils down the task, which is equivalent to a thread, except that it is more lightweight and comes without the overhead of the creating an OS thread of that. Now TPL, so in a TPL we have a fundamental concept called the task. So in a TPL, so what we do, so we do using a task code there. So whatever we do it using a task code there. So task is the fundamental concept in a TPL of that. So task is the fundamental concept in a TPL of that, and task is very lightweight. So if you go to the multi-threading, so in a multi-threading, thread is the fundamental concept, and thread is something that is created and managed by the OS of that. But here, so task is a fundamental concept in a TPL, and task is very lightweight, and we do not have overhead to create a OS thread for the task of that. So in other words, a task is an easier way to execute something asynchronously and parallelly compared to a thread. So in other words, we can say, so task is a easier way to execute something asynchronously and parallelly compared to thread of that. Now here, so compared to thread of that. Now here, so what we have is, so we have small we can say, so we'll have small, we can say, code snip which will help us to understand and learn the task with that. So let's try to understand how to create a task. Now to create the task we have the two options. So this task class has a factory proper object, and factory object has a start new method. So start new method will help you to create a task with that. So you can say task is one execution unit which will help you to execute some code. So you can say indirectly we can say, so task will help you to execute one method parallelly or concurrently. So task will help you to execute one method, or we can one method parallelly or concurrently, that depends on your requirement of that. So to create a task, we use the task dot factory dot start new method of a factory, and we pass a method that we want to execute concurrently, or we can say parallelly with them. And another option, so we can use the task constructor. So using a task constructor, we can also create the object of a task with them. Now let's create one console application here. So console application.NET framework. Now here I'll say also task example, and I'm putting this here in C# folder. Okay. Now, so I started a console application. So instead of writing the code from the scratch, so I'll just copy this code here, and if you paste it here. Now, if you look at to this code, so what we are doing, so we are creating one task using a start new method of a factory object that we have in a task class. So that's a task dot factory, and here we are saying the start new. So task dot factory, and here we are saying start new, and the task start new, so we can pass a method that we want to be executed as a task over there. But here what we are doing, so we are creating an anonymous method. If you remember the anonymous method syntax in the C# console that we had learned, so anonymous method without parameter, and in this method we are just saying console dot write line. This is the first method to create and start a task using TPL. So this is the first method. First method to create and start a task using a TPL. So this is the first method using which you can create and manage the task in a TPL with that. So this is the first method using which you can create and manage the task in the TPL with that. Fine. Now another way is we can use the constructor of a task. So another way is we can use the constructor of a task for that. So how we can use the constructor of a task, where task equal to new task, and in that constructor we can pass a method that we want to be executed as a task for that. And here what we did, so we had created an anonymous method. So here also we had created the anonymous method, and in this method we are just writing something in the console. This is the second method to create a task using TPL of that. Now then we are starting the task here. So here we are starting the task. So we will start the task here. So this will be started immediately as it created. So this will be started immediately as it created, and this will be started when you call the start method, because we are storing it into variable. So here we are not storing it into any variable. So here this need to be started using the start method. So start method will help you to start the task, and then we are just saying a message here. So program completed, and we can say something called a read key here. So we can say something called a read key here. Now run this using a control F5. So I'm running this using a control F5. So when we run this here, you'll get the output here. So if you read the output, so program complete, then this is the first method to create the start task TPL, and this is the second method to create a task using TPL. Now if you look at here, so if we assume this is the sequential execution, then what should happen? So at the first step it should display this is the first method to create, and then this is second method to create, and then it should display me program complete, and then we have this. But is it going to display that? No, it's not displaying here. Now if you run this several times, you'll find the changes here. So you'll find the changes. This is the first method to create the start task using TPL, program complete. This is the second method to create task TPL using TPL. As you run this again and again, you'll find the result will be little different. So you'll not find the same result. So now you got the program completed first, and this is the second method to create a task using TPL, and this is the first method to create the task using TPL of that. So what is happening? So this is not executing in a sequence, so this is not getting executed in the sequence of that. So this is not getting executed in a sequence, so this is not getting executed in the sequence of that. So if you look at here, so why it's not getting executed in sequence? Because we are we are not executing these methods one by one as a normal methods. We are executing it as in task, and tasks are always executed parallelly. So tasks are always executed parallelly or simultaneously with that. So this is get started, this is get started. So whatever the task that completes first, that will generate output, and the task that is not completed first, that will generate output later on. So it will not wait for any other task with that. Fine. So as you run this program again and again, you'll find a different output of that. If you do it sequentially, so you'll find the same output of that. Fine. Now, so if you run this code again and again, it will show different output. Why it will show the different output? Because that it's executing those two, we can say anonymous method, we can say independent of each other. So we can say simultaneously or parallelly with that. Okay. Now, so if you want to make any task wait, so if you want to make any task wait, so we can call the wait method on that particular task with that. So we can call the wait method on that task to make any task to wait with that. So wait start method to start the task if you store that task in some variable. Now if you do not store that task in the variable, and then it will be get started automatically as soon as it get created with them. And wait is a method which will block the, so sometimes we would like to wait for the task to complete before we proceed to the next step, and this will be a blocking operation. The next line of the code will be only executed after the task has been completed. So as below. So here we have created a task and we have stored that task into a variable. So we are task 1, then we are calling the wait method here, then task 2, then we are calling the wait method here, sorry, start and the wait method here, then we have this. So indirectly now we are using wait method. We are telling to the task 1 to wait in task 2, wait in task, then we are doing the thing with that. Now here we'll store this into some variables. So we'll say something called var task 1, or we'll say task 1 here, and here we'll say something called task 1 dot wait. So task 1 dot wait, and here we'll say something called task dot wait. So we have the task 1 dot wait here and task dot wait. So task 1 dot wait and task dot wait. Now in this scenario, what will happen? So this task will get started, even though it got finished, so it will wait. Then it will this, then it will wait, then this. So indirectly, this will be executed in a sequential way. So this is the first method to create the start task TPL. This is the second method to create a task TPL program complete. So indirectly this will be executed sequentially. So this will be executed sequentially here. So this will be executed sequentially. So you run this n number of times, you'll get the same output here. So you'll get the same output. So how many times you run doesn't matter, but it will get you the same out. So this is the first method to create the start task, and second method to create and start the task here. So you'll get the same output here. Okay. Now the next thing that we have here, so getting results from the task. So how to get the result from the task of that? So you can get the result from the task by using a result property. So we can use the result property of a task to get the result of that, and then we can use that result property to get the result here. Now many times you would need to get some result from the task, and how we can get the results. We can get this result using a result property, and this is a blocking, we can say, line. So blocking means it will block this execution until it doesn't get the result of that. Now how to get the result here? So we can get the result using a generic implementation of a task. So here if you look at here, so we had implemented task, that is the non-generic version here. So this is non-generic version. So if you do not want to return anything from the task, so if you do not want to return anything from the task, then you can use just a task. So that is the task, that is the non-generic implementation. And when you want to return the something from the task, then we need to implement a generic implementation of a task. So this is called non-generic implementation, and this is a generic implementation of that. So if you want to return something, so you need to specify the generic implementation, and here you need to specify the type that you want to return from the task of that. So the type that you want to return from the task here. Now let's return something from this. So if you look at to this code, so if I just copy this code instead of typing it again, and if I here if I paste it, so if I paste this code here, so what will happen? So when we run this, so you'll find something here. Oh sorry, so I think I copied it in the wrong place. Okay. So if you look at to this is the first method to create a task, and it's returning you the hello. So it's returning the hello. And if you look at here, so we have the generic implementation here. So in generic implementation, we put the angular bracket, and in angular bracket we can specify that type that you want to return. In angular bracket you can specify that type that you want to return here. So we want to return the string, so in angular bracket we are specifying the string here, and then we are returning the hello here. Now same way we'll create a new task using new task method, and here we are also returning this thing. But here if you look at here, so there is a small difference between the previous one and this one. Now I am creating the anonymous method using a func delegate. So I am creating the anonymous method using a func delegate. So func is a built-in delegate. Now this is a built-in delegate which will help you to create an anonymous method. So it will help you to create an anonymous method here, and here we pass the object as a parameter and string as a parameter. So we are passing the two parameters here, and then we have the anonymous method into this particular func delegate. So into this particular func delegate here, and then we are passing the value as a parameter here. Fine. Now I repeat, so what I want to do, so first thing I want to return something from the task. So the first thing that I want to return something from the task, so what I am doing, so I am creating a generic task here. So I am creating a generic task by passing a generic parameter. So whatever the type of value that you want to return, that you can pass here in angular brackets of that. Now what if you want to pass a value inside a task? What if you want to pass a value inside a task? What if you want to pass a value inside a task? So here is the result method, sorry, result property. So result property is the property of the task which will get you the result of this particular task for that. So it will get you the result of this particular task. So the result of the task is hello, and this hello will be available in a value 1. So this hello will be available in a value 1. So result is a property of a task which will get you the result of a task here. So we'll get the hello in a value 1 with that. Now I want to pass this value 1 as a parameter to a task with that. So I want to pass this value 1 as a parameter to the task. Now for that, so if you want to pass a parameter to the task, we need to create a task using a func delegate to that. So we need to create a task using a func delegate. So if you want to pass a parameter to the task, we need to create a task using a func delegate to that. And if you look at the func delegate, so it will have the first generic parameter is of type object and second generic parameter is of type string here. And in this func delegate, we have the two values. So in this in this func delegate, sorry, we have an anonymous method, and then we are passing a value 1 as a parameter to this particular constructor of a task. So we are passing this value as a parameter to this particular constructor of that. Now this is the anonymous method, and here what we are doing, so we are returning the string. So this is again a generic task, so it returns you the string here. So here from we are returning the string. So this value 1 will be passed as a parameter to this particular anonymous method, and then it will get you hello world. So it will get you the hello. So hello will be available in this value 1. So hello world, and that will be written from the task 2. So here we are starting the task 2, and then we are storing the result. So we are storing the result of a task 2 in the value 2 property, and we are displaying the value 2. Then we are displaying the program completed here. Now this way, so you can pass the parameter to the task, or you can return the parameter from the task. Now this is the first method to create and start a task using TPL, and this is the second method to create a task using TPL. And here we have the hello world. So here we have the hello space world explanation. So hello space world explanation here. Okay, so that is the result of a task 2. So task 2 result, we are storing the value 2 and we are displaying the value 2 here, and then at the end we are saying program completed. So at the end we are saying something called program completed here. Okay, now so at the end here we are saying something called program completed. Now, so what we can do here is, let us go further and we'll try to understand async and wait. So we don't want to go to in detail of the task, but we should have a basic idea of the task to understand the async and the await in C#. So here we need to remember, so async keyword turns a method into a asynchronous method. So when you define any method or any function in a C# using async keyword, so it will convert that particular method to asynchronous method. It will convert that method into asynchronous method, which allows you to use the await keyword in the its body. So asynchronous methods are the methods those will not wait for the execution of, we can say, another method. And when you create any async method, so in that async method you can use the await keyword. So I repeat, so await keyword can be used only in async method, and to make any method async, so we define that method using async keyword. And we can use the await method in the body of async method. So when the await keyword is applied, it suspends the calling method and yields the control back to the caller until the awaited task is completed with that. So this is the funda behind the asynchronous programming. So what is the funda of that? Suppose execution comes to async method, so execution comes to the async method, and if async method do some task by calling await keyword, so by using await keyword, so what await keyword will do, so await keyword will suspend the calling method and aids the control back to the caller until the await task is completed. So whatever the task that is supposed to be completed by the await, so until that task doesn't get completed, it will not block the execution execution of a program, so it will hand over the control to the calling method or a caller, so that that caller will continue its execution further, and as soon as this awaited task is completed, it will get back to the we can say caller, and the result will be available there. So this is the way asynchronous programming works with that. So this is the way asynchronous programming works with that. So async is a built-in keyword in C sharp. So when you apply the async keyword to any method, that method will become an asynchronous method. And asynchronous method is a method who has the capability to do the await. So who has the capability to perform the await operation. And await keyword, when called with any function or any kind of code, so it will suspend the current method, and it will hand over the control to the caller or calling method until that particular await task or await activity doesn't get completed with that. So await can only be used inside a sync method, that you need to remember. So await is basically used only inside a sync method. The return type of a sync method is always a task. So return type of the async method will be always a task. ये भी आपको याद रखना है. So you need to remember this. So async method can return only task or task of T. So task is a non-generic and task of T is a generic. Now it's checked by the compiler, so there is no much room for making mistakes here. So it's compulsory to return the task and or task of T from a async method there. And if you forgot to do that, no problem. So compiler will give you error. So compiler will give you error. So you need to do it. Now the await keyword, the advantage of async function only becomes apparent when you combine it with await keyword. So async method will get you the advantage or the whatever expected you the only when you use the await keyword. Without await keyword, you cannot realize the benefit or the advantage of the we can say async method of that. And await only works inside a async function or async method. The await keyword is used to asynchronously wait for a task or task T to complete, and it pauses the execution of a current method until the asynchronous task that's being awaited completes. So there, and it will hand over the execution to the caller, so that caller can continue its execution of that. Now here, so here we have a simple example to make a T using without async and await first, and then we are using async and await there. So then we are using async and await there. Now to avoid the spelling mistake, so what I'll do is I'll just copy this. So I'll copy this here and I'll paste it here. Okay, so if you look at here, so what we are doing basically here, okay, we do not need a namespace, so we need a class and the program. Okay, now if you look at to this, so we have a tprog class, and this tprog class has a make t method. Now to make the tea, what we need to do, so we need to boil the water, we need to take the cups off from the drawer and put the tea in the cup, then we pour the boiled water into it, and your tea will be ready. So these are the steps to we can say get your tea ready. So here, so boiling water is basically a different task, so we can do it separately. So for boiling water, so if I create a boil water method, and the boil water method, so what we are doing, so we can say start the kettle, and then we can say wait for the kettle to get we can say hot, and then this is the time period, so we are delaying this activity, that means 2000 millisecond time is required to get the kettle hot or boil the water. So once the water boiling is finished, so we are returning the hot water. So here we are calling the boil water method, and this boil water method will get me the hot water, and then we are taking the cup out of the drawer cell, put the tea in the cups and pour the water, and your tea will be ready with that. So we are returning this tea, and where we are realizing this t here, so we are creating object of this class, and we are calling a make t method, and here we are writing the r with that. Now if you run this, so if you run this, what is happening? Start the kettle, waiting for the kettle finish boil of the water, take the cup out of the drawer shelf and put the tea in the cups and pour the water in the cup, so your tea is ready. Okay, now is this a right way or efficient way to we can say create a tea, or to make the tea? No, this is not the right way. So if you look at here, so once you start the kettle, you do not need to wait for the kettle to get you a boiled water. So in between, while that kettle is boiling the water, so you can take the cups off from the shelf, and you can pour. We can put the tea inside the cup, and once the boiled water is available, then you can pour that boiled water into that particular cup of that to get the tea of that. So this is the more efficient way to perform such kind of activity or task of that. Now, so if you do the sequential execution, so you will not get we can say efficiency, or we can say performance, because you need to wait till the kettle provides you a boiled water. So even though you are free in a time where you can pick up the cups from the shelf or the drawer to make the we can say do that particular activity, you cannot do, because you need to wait for the boiled water from the kettle there, because that is going to happen in sequential programming with that. So that is going to happen in sequential programming. Now let's implement this using a async and await keyword. Now let's implement it using a async and await keyword. Now let's implement it using a async and await keyword. Suppose if I copy this program again, and if I paste this in a console application, so if I paste this in the console application here, okay. Now here I had made small changes. The first change that I did is I'll focus on the boil water. So now boil water is not a synchronous method. Now a boil water is not a synchronous method. So we made this boil water method async using async keyword, and just before I had told you, so if you make any method async, so that method should return a task with some data so that you want. So if you do not want to return anything, you just use the task. If you want to return something, you can the task generic version. Here you can pass the data. So what we are doing here, we are doing the same task here. Start the kettle, waiting for the kettle. So here, since this method is async, so waiting for the kettle. So as soon as we got the waiting for the kettle, so that water is getting boiled there. So it's taking a time to get the water boiled there. So that particular activity we are doing using await keyword. So that particular activity, so this is 2000 microseconds where that water is getting boiled inside kettle. So then this await keyword we are doing here. So await will suspend the execution of a boil water, and it will hand over the execution to the caller. So it will hand over the execution to the caller, so that caller can perform other activities there. So that the caller can perform the other activities there, and as soon as the result of this await is available, so it will prepare the result for you. And when you ask for that result, it will get you the result of that. So when you ask for that result, so it will prepare the result. So it will prepare the result without blocking this particular method, and when you ask for that result, it will get you that particular result to that. Now if you go to the make tea method, so you'll find something here. So what we are doing, so we are saying boil water, so we are calling a boil water method here. And in a boil water method, so once we call the boil water method, what boil water method will do, so it will await the boiling of the water task. So await the boiling of water task means it will suspend the execution of this method. It will do it in the background, and it will hand over the control to this particular method, so that in between, so while that water is getting boiled, so you can take the cup out of the drawer or shelf and put the tea inside the cup. And after this we are asking for the boiled water. So after this we are taking the boiled water. So how we are taking that boiled water? By awaiting this result. So by awaiting this particular result, so result of this boil water will be available in a boiling water variable, but that result will be realized when we call it using a await method. So when we say await and boil water, so it will get you the boiled water into the water variable. Then we are pouring hot water into the cup there, and our tea is ready. And since we are calling the await here, so we are using await here. So this method should be async, and it should return task, and here from we are returning the string, so it should return a task of type string with that. So it will get you the t inside the main method, and in the main method we are realizing that result using a result property of the task there, and we are displaying it here. Now after this, when we run this, so what is happening here, so start the kettle, waiting for the kettle. So you are waiting for the kettle. So at that time, you take the cup out of the drawer and shelf. Then we waiting for the kettle is finished, then we pour the hot water into the cup and your tea is ready with that. Now this is the right way, or we can say efficient way to make the tea. So in the programming world, so you'll find so many situations like this where you do not need to wait for a lot of things. So you want to continue doing some other stuff while something is getting executed. So instead of blocking the execution of a code for that particular thing which is getting executed with that, so we can await that particular thing and we can continue the execution of the regular thing using async method there. So using async method. Now this way we can use the async and await keyword there. So this way we can use the async and await keyword. Now, why we learn this async and await keyword? Because we want to use them in MVC controller. So we want to create async MVC controllers. So we want to create async MVC controllers of that. Now, why we should create async controller and how we should do it, that we'll see in the next session. So that will go to this particular thing in the next session. So why we need async control MVC controllers, and how to create async MVC controllers, and what is the advantage of the async MVC controllers, and where to use the async MVC controller and where not to use the async, or we can say MVC controller. That will talk in the next session there. So that will learn in the next session there. Fine. So today I'm going to stop at itself. Tomorrow we'll continue with your regular sessions, and on the next Sunday, so we'll go for async controller. So on the next Sunday we'll go for async MVC controller. So next Sunday we'll go for async MVC controllers. Now, if you have any kind of query or doubt, please ask me. Do anything. So it will just example. Suppose here we do not have a read key. If you run this using F5, sorry, so I'll share the screen here. Of F5 and control F5. So if you run this program using F5, so this program will not wait for the output. It will get terminated. So if you write something called console.read key, it will wait there until you do not you press some key. So now it will wait here to press the key. So it will not close the program directly. Now it's waiting to press the key.
Okay.
Okay, and we do not need this if you run this program using control F5. So if you run this using control F5, so we do not need a read key, because control F5 will show you the message press any key to continue. So control F5 will not close this prompt until you do not press any key. But if you run this using F5, so it will not get that message, it will terminate it automatically. So if you want to stop the termination, then we can use the read key. Now it will not terminate, it will wait to press any key. Okay,
Okay,
now
sir.
it's waiting. Any other doubt?